Okay, so now we want to take a look at solving each equation, and we're going to check our solutions. So first thing, we're going to use our properties. So I'm going to write log base 5 of m equals log base 5 of 125 to the 1/3. So log base 5 of m equals log base 5. I'm going to write that as cube root of 125. Well, notice now that we have log base 5 on both sides, we know m is equal to cube root of 125, so m is equal to 5. Okay, over here, part B, so we're going to move all the exponents. Well, it looks like that's the only one, so I have log base 3 of y squared plus log base 3 of 0.1 equals log base 3 of 5 plus log base 3 of 2. Okay, now I'm going to combine the additions into multiplication. So I have log base 3 of y squared times 0.1 equals log base 3 of 5 times 2. All right, now that I have log base 3 on both sides, I'm going to cross those out. So I'm just going to put 0.1 times y squared, and then we get 10 on the right side. Well, 1/10, if I multiply both sides by 10, I get y squared equals 100. So y would equal plus or minus 10, but remember, once we plug it back in, we can only have a logarithm of positive numbers, so we're just going to have y equals 10. Okay, with part C, we're going to move these. On the left side, I have log base 7 of m. On the right side, I'm going to have log base 7. So if you want, we could change that to a cube root right away. Oops. And with log base 7 of 121 to the 1/2, I'm just going to write that as square root. Okay, plus sign is going to turn into multiplication. So I'm going to have log base 7. Now, cube root of 64 is 4, and square root of 121 is 11, so I'm going to multiply those together. So that's kind of combining two steps. If that's confusing, then you can separate it into different steps. We get log 7 cancels, so m equals 44. All right, next one, we're going to change this plus to multiplication. There's no exponents to take care of. So x times x plus 5 equals 2. Now this one's a little bit different because notice we don't have a log on the right side. So if we only have one logarithm, we're going to rewrite this in exponential form. So remember, the little base becomes a big base. 2 is the exponent, equals x times x plus 5. So I'm going to write that as x squared plus 5x. So we get 36 on the left side. This gives us a quadratic. So we're going to see, does this factor? So we get x plus 9, x minus 4. So x equals -9 or x equals 4. But if we go back to the beginning, if we plug in -9, that would give us a negative logarithm. So it can only be x equals 4. Okay, next one, I'm going to put that over here. So that's going to be log base 2 of x to the 4th minus log base 2 of 5 equals log base 2 of 125. So I'm going to change that to division. Okay, now what can we do? So we have log base 2 on both sides. So I have x to the 4th over 5 equals 125. So this is going to give us x to the 4th equals 625. Okay, now I can't just You might be inclined to just take the fourth root, but we actually have to separate that out. So this is going to be x squared plus 25, and then x squared minus 25. This is the difference of two cubes. Now, x squared plus 25 equals 0, and x squared minus 25 equals 0. However, this is going to be an imaginary number, so we don't want that. And this is going to give us plus or minus 5, but we can only have positive values for x, so we're just going to get x equals 5. Okay, last one here. We're going to move that power to the x. And if you want, you can kind of combine that plus sign into multiplication right away. Now we have log base 7 on both sides. We can cancel it. So we get x squared equals 27 times 81. Now notice I didn't bother multiplying it out, because ultimately what am I going to end up doing? I'm going to end up doing a square root. Well, square root of 27 is 3 root 3, and square root of 81 is 9. So I would have 3 times 9 with a root 3 left over, which is 27 root 3.